Hello and welcome to another episode of the Geotechnical Engineering Podcast. Today's guest is Seth Scheilz, PE, Senior Geotechnical Engineer at Braun Intertech Corporation. Now, if you've been paying attention, you would have seen that Seth was on another one of our podcasts very recently, which is the Engineering Career Coach. There, he talked about what it takes to get people on your team to be able to advance in their careers as engineering consultants or engineers. Today, we're going to be focusing on something different because this is the Geotechnical Engineering Podcast. So Seth's going to be talking about subsurface exploration, and he's also going to be talking about advanced in-situ testing and what this means for geotechnical engineers. So I'm your host, Jared Green. I'm excited to bring you another episode of the Geotechnical Engineering Podcast. And with that, let's get right into today's episode.
This video is brought to you by Menard USA. Menard USA is a specialty ground improvement contractor that works nationally providing design-build ground improvement solutions at sites with problematic soils. Menard works closely with civil, structural, and geotechnical engineers to minimize foundation costs for wide ranges of soil conditions, structure types, and loading conditions. To learn more about Menard USA or for help on your next project, please visit www.menardusa.com.
All right, welcome to the show, Seth. How are you doing?
I'm doing well, Jared. How are you?
I'm good. I was really looking forward to this conversation, so I'm glad that we were able to carve out time where we could both talk. It would be great if you could tell our listeners a little bit more about yourself, talk a little bit about your background, and what are your typical daily activities consist of?
Yeah, so I'm a senior engineer with Braun Intertech in Kansas City. I support geotechnical aspects of projects for government entities, cities, counties, some commercial work, K-12, some heavy industry and utilities. So pretty broad range of projects. And within a given week, I wear many hats in the engineering consultant realm, whether that's meeting with clients, preparing proposals, performing engineering analyses, writing reports, or making site visits.
Great. And we're going to talk about subsurface exploration and the importance regarding subsurface exploration and also advanced in-situ testing. What are your thoughts?
Yeah, so earlier in my career, I was told about the cost of making changes throughout the design and construction process. And the way it was explained to me is really there are four main steps through that process. You have the proposal stage, the engineering analysis stage, procurement, and then finally construction. And kind of a good way that was explained to me was that for every time you advance a stage, it's a rough order of magnitude in cost to make a change, whether that's the design team making a change or the client requesting a change. So I think it's very important to try to define a project early in that proposal stage. Within that, as you move forward in the stages, we're adding value. So early on, spending money on additional in-situ testing may add value that reduces risk further down the line in the construction process. We are consultants to many parties. As I've mentioned, the owner could be the architect, civil engineer, structural engineer, would likely engage with the general contractor and the earthwork contractor. So there's significant value in asking many questions up front during the proposal stage and the early part of the design stage to truly understand that project, understanding the structural layout, loads, grading that may have to deal with retaining walls, slope stability, things like that. The more information we can gather on the front end, then we can put together a site-specific exploration to gather information to reduce geotechnical risk later on.
Got it. So spending a little more money in the beginning can help a project in the long run.
Yeah. So an example of that may be with cone penetration testing. It measures tip resistance, sleeve resistance. Most cones now measure pore pressure, some measure seismic. If you can get a continuous profile of your soil strength with depth, that may give you an increased bearing capacity, which would reduce concrete steel requirements. And project where put a basement in, and we're not concerned about that. About if we spend a little bit of money to core the rock now, and we can quantify its type, whether it's shale, maybe sandstone or limestone, that's going to impact his cost and reduce unknowns to the contractor when they have to excavate that material. Shale in the Kansas City area is more likely that can be excavated, where getting into limestone, it may have to be chipped out. And so we're spending money now in hopes that we can reduce that risk, reduce that unknown parameter, and provide better information to the contractor and get better pricing for our client.
No, it makes a lot of sense. And it could be the difference between a project, coming in under budget or over budget, right? If you're bringing the wrong equipment out there because you don't know you need to, hammer through rather than excavate through, it could be a big deal. It could be a big deal. All right. Mm-hmm. And I understand that you're a member of the Geo Institute's Engineering, Geology, and Site Characterization Committee. What advice would you have for geotechnical engineers that are looking to get more experience in subsurface exploration and in situ testing? What are some of the things that come to mind for you?
Yeah, so I joined that committee in January. So I'm new to the committee and learning how it operates. But to your question of trying to find more expertise and various exploration methods, large projects that are complicated scope, complex in geology are great places to look for different methods. These types of projects allow engineers that maybe have less experience to work with a seasoned engineer who can provide guidance on various testing types or methods. Additionally, larger projects generally have bigger budgets, which allow to make some site visits to better understand the layout of the site and how we're trying to place a building or a structure on the site. And additionally, you may be able to look at various methods. So if you have a site where you can do some cone penetration testing, you do your standard penetration test with split spoons, and you maybe take some Shelby tubes, then we have 3 different methods there where we can estimate the soil strength. We can use N values that correlate to soil strength. We can use our Shelby tubes to bring back to the lab and run unconfined compression tests. And we have correlations with the CPT, and then we can evaluate how those 3 methods estimate the soil strength across the site.
Great. And in your experience, how can geotechnical engineers effectively incorporate the results of subsurface exploration and advanced in situ testing into their design and analysis processes? What are your thoughts there?
Yeah, so as geotechnical engineers, we all know that soil is the most variable building material that we utilize. So there is no guarantee for success when collecting in situ parameters. Best practices would be in determining the likely soil types present on the site by performing a desktop review of publicly available data. That could be a soil survey from like the USDA, or a lot of states have public well log information. So that kind of gives you an idea of what you may encounter on a site. And then defining the needed soil parameters, again, going back to having that conversation with the design team and the owner of what we're trying to accomplish, allows us to determine what we need for our engineering calculations. And then we can move forward with the test and trying to collect the necessary data. And then finally, the engineer will evaluate the data to determine its quality before utilizing any of that information as part of their solution. And, at times you can get great data and other times not. Like, for example, I've had varying success using pressure meter testing. I had a project in the Southeast US where we were doing some pressure meter testing. So we had 5 to 10 feet of highly organic soils underlain by highly fractured limestone. And this soil was so soft that if you stood on it for, a few minutes, water would start to collect around your work boots because just the weight of the human was compressing the soil. And so we wanted to try to get data on that limestone layer. And so, as I mentioned, it was highly fractured. So it was more configured in a way that was like a loose gravel matrix. So as we would put the pressure meter in the ground and we would start to inflate the bladder with the water to expand it. As it would expand, the fins that protect the bladder would open up, and we had issues with the limestone falling in between the bladder or in between the fins and puncturing the bladder. Speaking from experience, rebuilding and recalibrating a pressure meter multiple times is not fun. But in another project here in the Kansas City area, I had the opportunity to use a pressure meter to define the lateral response for fat clays in the use of the design for transmission line foundations. And the volume pressure curves that we got from that testing added great value to the design team's understanding of how the near surface clay soils would react to lateral loads from the drilled piers. So I think it's always important to know that we plan explorations with best intentions, and then when we get to the field, we have to adapt. And sometimes we'll have great success, and other times we just make the best of it to collect data where we can.
That's a really good point. I mean, the reality is that we have to be flexible with what this exploration looks like. You plan it, but then when you get out there, things are going to change, or things could change.
Absolutely.
What are some of the specific challenges or considerations that geotechnical engineers should keep in mind when they're planning and implementing a subsurface exploration program?
So I really think there are two aspects. There's a technical aspect and a practical aspect. So I'll kind of speak to the technical one first. As I previously stated, soil and rock are highly variable materials, or they can be, and the subsurface exploration only evaluates a very small percentage of the material present on a given site. So when you think about it, you could have a site that could be a couple acres to hundreds of acres, and you can't quantify all that material. And so you have to place, borings and soundings and other types of testing in locations where we think it has the highest return. I recommend being flexible during the planning and data collection process. And, you could be out in the field collecting information, and if you're finding challenges, you adapt. And that could be something, for example, going back to the pressure meter, it might be the driller needs to adjust, the pressure for mud rotary. And so that way you get the right size diameter to fit the probe into the hole. So it's just being flexible and adapting as you're getting real-time information back from the tests that are being performed. And then second, I would say with the practice side, in my experience, I feel that there are clients and design team members that think exploration programs only consist of borings with split spoons and maybe Shelby tube samples. And so there is definitely a process of explaining new or unfamiliar testing methods to the other team members so that they understand it and that they're comfortable with it. And that basically it's that consulting role to convince them that you're recommending something that is adding value to their project.
I agree. What have your experiences been with the SPT torque, seismic CPT, PMT, and other testing techniques that have helped shape your career as a geotechnical engineer?
So I would say that having experience and gaining experience with all these different types of testing techniques provide me an opportunity to travel to different parts of the country. I've been able to experience many different geologies while performing the respective tests. Furthermore, it's a way to make a site visit. I think that's critical for geotechnical engineers, especially for younger geotechnical engineers, to go out and visit sites. At least for me, it helps me better visualize the existing topography and how the structure will be constructed on the site.
Got it. So because you are aware of these technologies, if there was a project coming up, I guess you would be the one that's sent to see this get done.
Yeah, I would be comfortable doing that.
Got it. And based on your knowledge and your expertise, what emerging technologies or methodologies do you believe geotechnical engineers should be aware of, and also they should explore for their professional growth?
Yeah, so really two came to mind for me. One that I want to learn more about in an area of growth is the use of photogrammetry or LiDAR to monitor ground movement or deformations over a given period of time. Traditionally, an exploration helps us understand the subsurface conditions at a given point in time, but we don't know necessarily what it was like previous or what it was like after. And so I think using these technologies, which helps monitor site changes over time, provides further information on how to plan an exploration and gives us some more insight on how a site is changing over time. Second thing that I think will be interesting to see in the coming years, at the Kansas City Geo Institute chapter's annual Geotechnical conference held this past April, Dr. Jean Benoit, who is a professor emeritus at the University of New Hampshire, gave a presentation on state DOTs that are instrumenting drill rigs. I think this is an effort that's being pushed and maybe some funding from the Federal Highway Administration. But they're instrumenting your standard drill rigs to better understand soil properties between sampling depths. And so it kind of reminds me a little bit of a cross between a CPT sounding and the instrumentation of like an auger cast in place pile drill rig. And so things that it's measuring are downforce and torque, drilling fluid pressure, penetration rate. There's a lot of parameters that they're starting to look at. And so it's just trying to, again, we've mobilized to the field. We have equipment out there. How do we capture more information about the limited soil that we're encountering? And how can we use that information to reduce risk? So I think that's definitely an effort that we'll see from the state DOTs and likely in private industry in the coming years.
Yep, I think that I agree with you. I was at a conference a few months ago and saw quite a few paper presentations on measurement while drilling. And, there's a lot of information that's being gathered. So how we use it's going to be the question, but, looking forward to seeing where that goes. So we talked quite a bit about subsurface explorations and advanced in situ testing, but can you think of a time that a subsurface exploration or in situ testing actually had a significant impact on a project? Can you think of something specific just to give our listeners and viewers an idea of where we can go with this?
Yeah, so about 10 years ago, it was pretty early in my career, I was working on a large exploration for a 4-mile long sewer conveyance tunnel in the New England area. And so the project, before I was involved, did some preliminary borings to kind of see what they were experiencing or what they would likely encounter with the boring machine. And everything was pointing to clay underlain by granite. They had found some basalt in the area, but it was generally south of the tunnel alignment. And so they were wanting to put that tunnel within the granite strata. And so the lead geologist on that project had planned a couple angled borings to conduct. And that's something I'd never experienced before. So that was the first time doing that. And it was a really interesting process to set the equipment up like that. But as the coring progressed and that angled boring, we basically punched or cored through the granite and we encountered basalt. That was something that was not anticipated, and that became highly valuable information to gain as much information on that location of where this deeper basalt had crossed into the proposed alignment. And so, vertical borings in the area indicated that we would have likely encountered granite, but we just had this one area where it kind of it crossed over. And so, punching a vertical boring on each side, we would have missed it. So this discovery of the basalt resulted in a revised tunnel alignment. And so then the design team went back and moved that alignment to the north to avoid the basalt. And then we went back and did additional borings to confirm that we would likely be in granite material.
That's a big deal. It's not easy to change in alignment. So that was an important finding. I'm sure that was helpful for your project.
Yeah.
All right, great. How can geotechnical engineers stay up to date with latest advancements and research in subsurface exploration and in situ testing? And if there are any resources or communities that you'd recommend for continuous learning, that would be great. And we'll include those in the show notes as well.
Yeah. So first, I think I would recommend talking to professionals within your own organization that are experienced engineers. They've had worked on a lot of projects. They have lots of experience, so there could be some good mentoring there. Second, I personally enjoy reading Geostrata, the bi-monthly magazine published by ASCE's Geo Institute. I think there's a lot of good information in there. Usually you get some background on the exploration and how that information was used for the project. It's written at a little less of a technical level, so you can digest it pretty quickly. Third, I think attending a local or regional geotechnical conference would be beneficial to engineers. Many larger cities have a Geo Institute chapter, and they host annual conferences or seminars on geotechnical related topics. And then I think finally, engineers that really want to learn about a specific topic can search the literature for journal articles and other technical publications related to testing. I'm a big proponent of CPT, so I've read many CPT related publications authored by Dr. Peter Robertson and Dr. Paul Main. Both of them have some manuals that provide additional guidance on CPT testing procedure and how to utilize data for design.
Very good resources. Very good resources. We'll make sure to get those in the show notes. I was just saw Paul Main some weeks ago. He's big on the cones. Big on the cones.
Yes, he is.
All right. Well, before we take our break, what's the final piece of advice you'd like to give geotechnical engineers who are aspiring to make a meaningful contribution to the field of subsurface exploration and advanced in situ testing throughout their careers?
Yeah, so I recommend that engineers learn the why, how, and what about any type of in situ testing they're performing. They need to understand the why, as in why the test is needed for the specific project and soil condition. They need to learn how to perform the test to collect high quality data for the given soil parameter. And finally, they need to understand what the parameter is used for so they can improve their engineering analysis.
Very nice. Very nice. Well, thank you so much for all of that. We're going to come back in just a minute and close this one out with Seth in our Career Factor Safety In segment. Stick around. All right, welcome back. It's time for our Career Factor Safety In segment. In geotechnical engineering, just like many disciplines of engineering, it's important to incorporate a factor of safety into your design. But what about incorporating a factor of safety into your career? Today, of course, we're speaking with Seth Scheilz of Braun Intertech Corporation. Seth, you've already had a very successful career. Now, when you look back on your career, what's something that you've implemented in your career to give yourself, let's call it a factor of safety in your career?
Yeah, so I think the ability to continuously learn is of great value. Learning about new testing methods, new industries, those type of things have provided me with that factor of safety. Anyone who's willing to say yes and learn new things will be presented with new opportunities to grow and advance their career. I'll give you an example. So a few years ago, providing geotechnical recommendations for the railroad industry wasn't on my radar. It just wasn't a client that was part of any firm that I was working for. Since joining Braun, I've had the opportunity to work with one of the leading geotechnical engineers who supports the railroad industry. And in the past year, I've expanded my knowledge on track substructure, subballast and ballast materials, and common construction methodology in remote areas. So I would just encourage engineers to keep looking for those new opportunities. And when you're presented with one, say yes and contribute where you can and learn along the way.
That's great. Say yes. You can't go wrong when you say yes. All right, Seth. Well, thank you for coming on and for sharing all the great insights with us. You shared some great information and advice I know is going to be helpful for our listeners and those that are watching. If somebody wanted to reach out to you, how can they find you? You have an email address you want to share, or you're on social media?
So I'm on LinkedIn. That's the best way to connect with me. I check it pretty often. I try to be somewhat active, so that would be a good way to connect.
Excellent. Excellent. We'll make sure we get that link in the show notes. So thank you for coming on. This is a lot of fun. It's great, Seth.
Thanks for having me, Jared.
I hope you enjoyed the episode today. We would love to hear your feedback, comments, and/or questions. Please feel free to go to geotechnicalengineeringpodcast.com, where you'll find a summary of the key points discussed in today's episode, that being episode 81, as well as links to any of the resources, websites, or books mentioned during this episode. Until next time, we wish you the very best in all of your geotechnical engineering endeavors. Peace.